Hello and welcome again to Wisdom Technical Center, and welcome back from holidays and good anytime. Today in this channel we are going to continue on our chapter 3, which was on transistors. We are starting from transistors, that's the BJTs, marching towards the FETs, and if we get tired, then we shall visit the next village, MOSFET. Not forgetting that the BJT and FET got married to born the big boss, IGBTs. Now, I will quickly wrap up on how we got here today with this short story about transistors. It was during the beginning, early in the years 1900s, to control current, our only option was to use a vacuum tube. And during that era, that time, the vacuum tubes, they consumed a high amount of power and they were also very fragile. So during the Second World War, these vacuum tubes did not react well to explosions and gunfires. Now, at the end of the war, some great scientists came up with a method of controlling current in a solid state. And by doing so, they really began their research in the study of materials. And we learned here that materials that have 3 or fewer electrons on the valence shell, making them a good conductor. Those with 5 or more makes them a good insulator, and those with 4 and only 4 electrons on the valence shell are semiconductor materials. So we scientists look at those materials that have 4 electrons in the valence shell, which are silicon, germanium, and carbon. And silicon was at the top of the list as the most popular solid-state material used. So the first real component that was invented in the solid-state form was really the diode, the p-n junction diode. And the neat thing about the p-n junction diode is a diode is like a one-way check valve or like a turnstile. It allows you to only go one way, just like a p-n junction diode that allows current to flow through it in one direction only and blocks current that try to flow the opposite direction. Now, a check valve or turnstile, if we forced them the wrong direction, we could probably push hard enough against them and break through. Like a diode, if current is trying to flow backwards and it is strong enough, it will break the diode. Now, keep in mind that all diodes have its limit. But for generally speaking, the turnstiles allows traffic to only flow in one direction, same as diode allows current to only flow in one direction. These diodes were not good enough, though they were pretty fine in some uses. So came a guy by name Terence Zener, and this guy came up with a diode that intentionally can be operated in the reversed condition. And when it operated effectively in this reverse condition, what it will do is it will regulate voltage to a constant value. So Zener diode is the first real voltage regulator that you would study in this program. Voltage regulation is very, very important because in electronics, the proper operation of electronic circuits is critical on having a constant voltage. So by using a Zener diode in power supplies, it gives us these constant voltages outputs, which makes our circuit very, very stable for us. Now, an example of a voltage regulator by using a Zener diode can be used to build up our phone chargers at a constant 5 volts to charge our batteries or any other rechargeable battery less than 5 volts. Now, the next revolutionary process in the development of semiconductors in solid state was the development of transistors. And we are going to talk about the bipolar junction transistor today in this tutorial. So as from this point forward, whenever you hear the word transistor, I want you to think of really two different scenarios. First, a transistor could be used as a switch, just like the switches of our home outlet. This switch can either be open where the light is off, or the switch can be closed when the light is on. So this is one way that I could use a transistor. The second way that I could use a transistor is like how water flows through a tap. Current flows through a transistor like how water is flowing through the tap, because we can control really the amount of water flowing by adjusting the handle. So by adjusting the handle, we could either increase or decrease the velocity or the speed of flow of water. Same for transistors. By adjusting the voltage on a transistor, you could either increase or decrease the flow of current walking through it. Therefore, you can use it to actually control current that's flowing through a device. Whenever you see a transistor in a circuit, you got to think of these two different ways. Using it as a switch or using it as a controlling device. Now, the objective of this tutorial is not only the structure and history of transistors, but after a small short introduction about transistors, we shall move on to our main topic, the bipolar junction transistor, BJT. I know you may have heard of the BJTs, the JFETs, MOSFET, IGBTs, or the NPN, the N channel, or the P channel, and many other more. But you may find trouble to distinguish them. Therefore, here in this tutorial, we will basically learn that all 3 pins circuit elements or components are not only transistors. So therefore, transistors are classified into 2 main groups, the BJTs and the FETs. BJTs stands for the bipolar junction transistor, and FET stands for the field effect transistors. So the task or function of both transistors is to provide current control or voltage amplification as a switch. Now we shall see briefly the difference between them, that BJTs uses current to control current that is flowing through it, while the FETs uses voltage to control voltage and current. Now let's jump onto our main topic, the bipolar junction transistors, BJT. The bipolar junction transistor construction is very similar to that of a diode, except we are adding another layer or terminal to it. And back to review, we only have two types of solid-state materials, which are the N-type material and the P-type material. So by adding another layer, it got to be either the N material or the P material. You only have two materials to choose from. These devices can be used as switches where you could use a small amount of current to drive a larger current to power something. Let's say like a DC motor, or you could use them to amplify a small AC signal. So now we are going to talk about two types of BJTs. The NPN type BJT transistor and the PNP type BJT transistor. These two types of transistors are known as the bipolar junction transistors, and that they have two junctions. This component can be indicated on a circuit board or on any engineering drawing by the capital letter Q, meaning transistor, or the quiescent point of a transistor, which is an important factor or parameter of this device. Transistors can be constructed out of germanium or silicon. It consists instead of three doped regions. The regions are arranged into two different ways. First, it could be a P-type material that is sandwiched by two pieces of N-type materials, or an N-type material that is sandwiched between two pieces of P-type materials. Now, the first one is an NPN transistor because we have the N material, the P material in the middle, and an N material. The second is a PNP transistor because we have the P material, and now in the middle is an N-type material and a P material. So before we continue, I got to introduce to you some new terms. If you remember, the diode had an anode and a cathode, but transistors has three leads or terminals, but they have unique names to them. These unique names are the emitter, the base, and the collector. And now we are starting with the NPN transistor, and this is the internal three layers of NPN transistor. So here is one way to describe the NPN transistor. The first junction is at the left here. It's between the P-type and the N-type semiconductor. And at the right is the second junction, as you can see. So, bi means two, right? Therefore, we have a bipolar junction transistor. Now, one thing you have to remember about the arrow when it comes to solid-state devices is the arrow always points in the direction of hole flow, or in the direction of the conventional current. But as an electronician, we embrace electrons, or our interest is to study the behavior of electrons and how we can use them to perform a function. So electrons must be flowing against the arrow, since the electron current flows from the negative terminal